what are you asking us to share? Oh, there we are. They are going to
Okay.
share the poster.
Okay. Hi everyone. My name is Shay Iyer. Thank you so much for letting me present my project, Hydrogen Peroxide Fogging of Isolation Gowns, Disinfection Efficacy, and VOC Emissions. Let's begin. On the agenda today, I have the introduction, the background information, the hypotheses, the methodology, the statistical analysis, the results, and then the conclusion. The next healthcare crisis will occur in landfills and not in hospitals. Today I will be talking to you about an impending medical waste crisis from isolation gowns and a solution. We will discuss the environmental crisis from the disposal of single-use isolation gowns and a solution of disinfection and reuse of isolation gowns. 1.6 million tons of PPE waste is generated daily worldwide, and 85% of this by weight is isolation gowns. An average of 33 isolation gowns are used per stable patient per day in the United States, and more in unstable patients. Johns Hopkins University has estimated that if there is another 100-day wave from a COVID variant, an estimated 321 million more isolation gowns will be needed in the United States alone. The impact on the environment is fourfold. The manufacture of gowns with non-degradable materials such as SMS, polypropylene, and polyethylene has led to a burden on landfills and overflow into the ocean and the environment. Pathogens on the gowns after use leach into groundwater and pollute the air. The generation of micro and nanoplastics is harming ocean life, entire ecosystems, and is causing non-communicable diseases in humans. Regular incineration leads to the formation of toxic ash, which still requires landfilling. While reusable gowns manufactured with compostable materials and hydrothermal destruction of isolation gowns have been proposed and evaluated, none has gained traction as a solution. 80% of United States hospitals are still using single-use isolation gowns today. Our previous studies showed that fogging of gowns with hydrogen peroxide and hypochlorous acid results in similar efficacy to ethylene oxide sterilization, but this was in an uncontaminated gown scenario. We wanted to evaluate efficacy of hydrogen peroxide fogging in a heavily contaminated gown scenario with 2 of 4 of the more common healthcare-associated pathogens, and also evaluate safety by measuring the generation of volatile organic compounds, or VOCs, with standard fogging versus the addition of vacuum aeration to remove byproducts and to remove excess disinfectant. The material's composition was not part of the study. Our efficacy hypotheses were that hydrogen peroxide fogging will effectively lower the CFUs for both S. epidermidis and E. coli, and that the efficacy would be greater for E. coli as S. epidermidis is catalase positive and can degrade hydrogen peroxide. Our safety hypothesis was that with the addition of vacuum aeration, the VOCs will be lower at all time points in the 4-hour drying phase than without vacuum aeration. Next, we will discuss how we did this efficacy portion and the safety portion of the study. Let's talk about the methodology in the blue chevron boxes on the bottom left of my poster. We first transferred agar slants of S. epidermidis and E. coli onto the nutrient agar plates using a streaked plate method and incubated them for 48 hours at 37 degrees Celsius. This was to grow a pure culture that could be then transferred for inoculation. We took 15 ethylene oxide sterilized gowns that were pre-marked prior to sterilization with a 12 by 5 inch rectangle in the torso that was divided into 4 quadrants. For each of the bacterial groups, a 0.5 McFarland equivalent suspension was made to serve as the inoculum, and that can be shown in figure 2. If we can shift our attention to figure 3, from here, one sterile Q-tip was used to transfer the suspension into quadrant A, one half of the Q-tip, and quadrant B, the other half of the Q-tip. And a second Q-tip was then used in the same manner to inoculate quadrants C and D, with 5 minutes of drying time after inoculation. The pre-disinfection cultures were then obtained, with one culture per gown in quadrants A and C inside and outside the gown. Then gowns were fogged using 9% hydrogen peroxide for 1 minute and 30 seconds, or using a commercial fogger, and fogged the whole gown, not just the torso, for 1 minute and 30 seconds. 4 hours of drying time was then instituted immediately after fogging. Post-disinfection cultures were then obtained, again with one culture per gown in quadrants B and D inside and outside. Then we incubated the cultures at 37 degrees Celsius for 72 hours, and 2 readers read out colony-forming units and morphology. For the safety component of the study, 5 gowns were fogged with 9% hydrogen peroxide and placed in one room of 1280 cubic feet with a steady temperature of 22.2 degrees Celsius and 60% humidity. VOCs were measured using an SGP-41 sensor remotely via air gradient dashboard over 4 hours. Then 5 gowns were fogged with 9% hydrogen peroxide, then 30 minutes of vacuum assistance, then VOCs were measured remotely. They were recorded as unit list TVOC index of 1 to 500 and also as parts per million. No study is complete without statistical analysis, right? We had planned on using Friedman, Wilcoxon, and Mann-Whitney U-tests, but did not use them as the percent reduction was 100% with no variability. The percent reduction was calculated by as shown on the statistical analysis portion of the poster. For CFUs greater than 200, they were recorded as 200 plus, as it is standard with contact plates. The VOCs were calculated as deltas to account for the differences in baseline values, which are baseline corrected values. Let's go over our results. If we look at the efficacy results for S. epidermidis, all pre-disinfection CFUs were high and all post-disinfection CFUs were 0. This was represented in 2 ways in Figure 7 and Figure 9 in the efficacy results part. The dashed line is pre-disinfection and the solid line is post-disinfection. If we look at efficacy results for E. coli, the results were similar in that all CFUs pre-disinfection were 200 plus and all post-disinfection CFUs were 0. This is represented in Figure 10 and Figure 12, also in the efficacy results for the E. coli portion. The dashed line again is pre-disinfection and the solid line is post-disinfection. Figure 8 and Figure 11 in the efficacy results show contact plates marked with microbial growth pre-disinfection for both organisms and no growth post-disinfection. Figure 13 in the safety results represents VOCs generated with and without vacuum assistance. The left images, A and C, are VOC index of 1 to 500 values, and the right images, B and D, are VOC index in parts per million. And VOC in parts per million. The baseline prior to fogging from the room was obtained to calculate the deltas at all points. The dashed line represents no vacuum and the solid line represents vacuum assistance. At all time points, vacuum assistance resulted in keeping the VOC below the established safety threshold of 200. Our results allowed us to accept our first hypothesis as fogging with 9% hydrogen peroxide resulted in complete elimination of all organisms. Our second hypothesis was actually rejected as the efficacy was the same for both E. coli as well as S. epidermidis, which resulted in 0 CFUs post-disinfection. The addition of vacuum aeration resulted in VOCs below the safety threshold of 200 at all time points, making the addition of this step to the fogging invaluable. However, we had some limitations to this study. Our study goal was safety and efficacy. We have not undertaken a material composition testing to see if gowns can withstand repeated use. A study by Saini et al. Showed that coveralls made of materials similar to isolation gowns did not show changes to material composition, allowing for reuse. We hope this is the same for isolation gowns. I'm hopeful someone in this conference can help me with this. We only evaluated level 2 isolation gowns, which are the most commonly used, but other levels need to be studied. Other pathogens and minimum efficacious concentration of hydrogen peroxide are other avenues for a future study. My references are in the QR code at the bottom right of the poster. I'm also happy to email a list to anyone who would like them. With a note of finality, thank you so much for allowing me to present my project. I thank everyone here as well as my mentors and Mr. Greenberg, my science research teacher, for encouraging me. If there are any opportunities for me to be part of any research in your organization, please let me know. I will put my email in the chat box when I finish. Thank you again. Now, are there any questions?
Thank you, Shay, for the presentation. Any questions or comments from anyone of the participants, please? You may please proceed ahead. So, Shay, I think the exposure time of 1 minute 30 seconds is quite short. Did you explore whether the longer fogging durations offer any added benefit or are unnecessary?
I evaluated fogging times in my last study. I evaluated fogging times in my last study, and we found that 1 minute and 30 seconds was actually on the higher end for fogging time. So we used 1 minute and 30 seconds to, like, just as a baseline, so it would get rid of, we hope it would get rid of all the bacteria on the gowns.
And it did.
Yeah, and it did.
Interesting. One last question on the comment. Let's see. Do you track the VOC levels immediately after drying to determine how long it actually takes before it's safe for handling?
Yeah, we did. The VOCs for vacuum aeration, well, immediately after were safe to handle because during the entire drying time of 4 hours, it was less than the safety threshold of 200. However, without vacuum aeration, it was much higher than the safety threshold of 200 immediately after.
Interesting. One comment I see is exceptionally well done work, Shay, especially for someone so early in their research career. The clarity and confidence were impressive.
Thank you so much.
Thank you, Shay. Anybody else got any questions or comments? Please proceed ahead. All good, Shay. Thank you so much for the poster, and thanks for joining the conference too.
Thank you so much for letting me present today.
Thank you. All right, so no questions, then we move on to the next presentation. This presentation, the next session, going to be oral presentations. We have Dr. Mohammed Kamil.